let us solve this differential equation using the integrating factor. Right? Now, you can use the integrating factor because if you make some minor modifications here, you're going to find that this equation is of the form dy by dx plus py equals q. And the integrating factor, remember what it is? It is e to the integral of p dx. Alright. And remember from our previous video what you do next. You're going to multiply each side by the integrating factor. Alright, so let us look at the equation. No, it's not exactly in this form. You need to divide by x. Because remember, in this form, you don't have a number times dy by dx here. It's really 1 times dy by dx. So you need to get rid of this x here. So let's divide by x. You have dy by dx. X would cancel itself. Minus, this would be y over x equals, you're going to divide each of these by x. So let's see what will happen. X cubed over x would be x squared plus 3x squared over x would be 3x minus 2x divided by x would be 2. Alright, so now you have it in the form dy by dx plus py equal q. Let's rewrite this part, the left hand side. What you have is dy by dx plus negative 1 over x y. So I separate the p's from the y so you can see clearly. So x squared plus 3x minus 2. Alright. Now, you can see that p is equal to negative 1 over x. Right? And q, of course, is x squared plus 3x minus 2. Now, the integrating factor here is e to the integral of p dx, but p is negative 1 over x dx. Now let's rewrite it a bit. It would be e to the integral of, well, you have a negative there. So you can put the negative, it's like putting negative 1 outside the integral sign, you know, and multiply it by the integral of 1 over x dx. Right? Now, what is the integral of 1 over x? It is ln x. So what we have is e to the negative ln x. Right? Of course, you have plus c. The thing there, the constant of integration. But the thing is now, you won't need to have it on the left hand side. So you would have a constant on the left and on the right, but both of them you could subtract the constant from the left. It goes and subtract from the right, and you have a third constant. So it's not necessary to have a constant of integration here. All right. So you can just leave that out for now. Or just leave that out. Now, e to the negative ln x. Now, here, this is the same as 1 over e to the ln x. Because remember, e to a negative power is the same as 1 over e to the positive power. Alright? But e to the ln x is what? E and ln would cancel each other. E to the power would be the antilog and ln would be the log. So antilog and log cancel each other. So what you have is x, so it's 1 over x. So therefore, the integral of e to the p dx, in this case it becomes 1 over x. Turns out to be 1 over x. So let's multiply both sides by it. Alright? So here, we multiply both sides by e to the integral of p dx, which is the same as, in our case, 1 over x. So, what would happen? When we do that multiplication, we're going to have 1 over x times dy by dx. So it's 1 over x dy by dx. Alright. So 1 over x dy by dx minus 1 over x times y over x. So minus 1 over x times y over x, and then equal 1 over x times each of these. So it's really going to be x squared over x plus, alright, so x squared plus 3x minus 2 all over x equal x squared plus 3x minus 2. You multiply by 1 over x, the same as dividing by x. Alright, so let's fix this up a bit. This is 1 over x dy by dx minus, this will be y over x squared. See that? Equals, let's divide up now. X squared over x would be x. It's x plus 3x over x is 3 minus 2 over x. So that's what you have there. Right? Now, what is this? If you consider it, it ought to be, as I said before in the explanation in the previous video, the product or the result of a differentiation using the product rule. Now, what did you hold and what did you differentiate in each case? It seems here that you hold 1 over x and differentiate y with respect to x. So one of these things is 1 over x, right? And then the other would be y. But let's see what happens over here. If you differentiate 1 over x with respect to x, what will happen? This would be d by dx of 1 over x is the same as the derivative with respect to x of x to the negative 1, which would be multiplied by the power negative 1 times x to the reduced the whole power by 1, negative 2. So this would be negative 1 times 1 over x squared. So it becomes negative because of the negative 1, and under the line the denominator is x squared, so it is y. So here, if you differentiate this using the product rule, d by dx of 1 over xy, you hold 1 over x, differentiate y with respect to x, plus you hold y, differentiate 1 over x with respect to x, you get a negative, and under the line you get an x squared. So that's exactly what happens here. Alright? So now, here, let's just get rid of this to make space. this is equal to x plus 3 minus 2 over x. Alright, so here we have that. The next step is, remember what to do? You integrate both sides. And of course, why you integrate is to get rid of this d by dx business here. Right? So you want x and y out by themselves. But you have a d by dx of a function of x and y. So you integrate in order to cancel out the d by dx, the derivative. So what you have is the integral of d by dx of, we can call this y over x now, right? The integral of this dx is equal to the integral of x plus 3 minus 2 over x dx. Alright? So, let's see what happens here. The integral and derivative, those cancel each other. So what you have is y over x equals, integrate x, you get x squared over 2, plus you integrate 3, you're going to get 3x, minus, you integrate 2 over x, which is going to be minus 2 ln x, then plus your constant of integration, call it c. Right? So that's what we have so far. Now here you can neat it up a bit. Suppose we multiply both sides by x. You have y equals, well, this would be x cubed over 2 plus 3x squared minus 2x ln x plus, well, cx. So that would be cx. And then we want everything flat. So suppose we multiply both sides by 2. We would say 2y equals x cubed plus, this would be 3 2 6 x squared minus, this would be 2 2's 4 x ln x plus, but if we multiply c by 2, we get another constant, because instead of saying 2c times x, let's say d times x. Let's call that new constant d. Alright? So these last steps is just to try and make it a bit neater. But if you're in exam, you wouldn't probably have the time to be doing all of that. But you solve it, you know, essentially, you solve it here. But you made it a bit more appealing, right? A bit neater here. You wouldn't necessarily have to go down to this, all the way down to this step, right? You could stop here, or even here, right? I'll give you the full mark for reaching that point, because you showed that you know what you're doing once you reach that point. Alright? So you showed your competence in solving this type of equation. Alright, so that's it for now. I'll see you in the next video.